So welcome students. So in this question you are given an equation x power 7 plus 14x power 5 plus 16x cube plus 30x minus 560 is equal to 0. You are asked to find the number of real roots to this equation. Obviously this is a 7th degree equation. You have no hope of getting the solutions directly. So if you want to solve this equation, that's beyond your capability. So you have to guess that this question is based on some other concept. And if you observe this equation carefully, this equation has only odd powers of x. This is an important thing that you need to note in this question. So now what I do is, so let me take f of x is equal to x power 7 plus 14x power 5 plus 16x cube plus 30x minus 560. Now if I draw the graph of this, what is the relation between the graph of this function and the roots of this equation? So if you draw the graph of this, the number of points where this graph cuts x-axis is nothing but the number of roots of this equation. The number of points where this graph cuts the x-axis, and each point of that corresponds to a solution of this. So now if I want the number of solutions to this, I just need to find how many points will this curve cuts x-axis. So to do that, let me take f dash of x. What is f dash of x? That is nothing but 7 times x power 6 plus 14 into 5 is 70 times x power 4 plus 48 times x square plus 30. Right? So this is f dash of x. And if you observe carefully here, there is something interesting in this expression. So all the powers are even. That means this expression is always greater than 0. Because whether x is positive or negative, this term is positive, 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 positive. All the terms are positives. Hence, this is always greater than 0. That means f dash is always greater than 0. This implies f of x is monotonically increasing. F of x is always increasing. Hence, if you draw the graph of f of x, so how does the graph of f of x look? It always increases. It never comes back. That means, how many points will this curve cut x-axis? It can cut x-axis at only one point, right? If it has to cut x-axis at the next point, it has to turn back and come back. So, but f of x is monotonically increasing. That means it does not turn. It just goes up and up. So, we have only one point where this function meets x-axis. That means this equation has only one real root.